Hello and welcome to this session on the Big Bang, where we consider what the Big Bang is and look at the evidence which supports it. So first of all, what is the Big Bang? Well, it's the idea that the universe began as a singular point at which space and time and matter and energy were all created, and the universe has been expanding ever since. So it starts off with a Big Bang. Obviously, there not being any universe or space means we wouldn't be able to hear it, but it's a nice term nevertheless. And it's really broadly accepted now, although quite interestingly there's been some other models quite recently over the last few weeks which have considered the Big Bang model redundant if we look at some certain values using quantum mechanics. But for now we're going to stick with the Big Bang model because it's what's accepted in the IB syllabus, and it says about 12 to 14 billion years ago the universe we see today was just a few millimeters across, and since then it's expanded from this hot dense state into the vast, much cooler cosmos. Now, what evidence is there to support this crazy idea? Well, there's a number of key pieces which you need to know about. First of all, we think about the Doppler effect. Okay, now we know how the Doppler effect works. There's a change in the observed spectrum, let's say if we compare the absorption lines from our sun and the absorption lines from a star a long way away in a distant supercluster, we see that those absorption lines have been shifted, and they've been shifted in the red direction, so therefore it's redshifted. Now, they use Doppler shift to calculate how fast stars and other astronomical units are moving away from planet Earth. So that means that this is really important because Edwin Hubble and Milton Hermansen recognized that the spectra of distant galaxies all showed redshift, which means that they're all moving away from Earth no matter what direction we're looking in. Now, that doesn't mean that the Earth was the center of the universe. It implies that all parts of the universe are expanding away from each other. One model of this is to imagine if you are on the surface of a balloon and that balloon is blown up, you'll see that all the other points on the balloon are moving away from you. And this means if we work backwards, at some point all the particles must have been much closer together in the past. So the Doppler effect is one thing which we observe. The amount of helium. Two physicists called Deacon Peebles recognized that there was way more helium in the universe than could have been produced by stars. So that indicated that the universe at some point had high enough temperatures to allow helium production by fusion. In turn, they thought about if there was enough energetic radiation to be produced, then that means that as the universe expanded, it must have cooled down. So they thought that, along with this thinking, that there should be evidence of the temperature of the universe having cooled down from all that time ago, and they worked out that the maximum wavelength should correspond to a black body spectrum of about 3 Kelvin. And if we think about black body spectrums, the temperature of about 3 Kelvin would mean we'd be looking for microwave radiation. As it happened, shortly after this prediction, two scientists, Penzias and Wilson, were working on a microwave aerial, and they discovered that no matter what direction they pointed the aerial, it continued to pick up a steady and continuous background radiation in every single direction. So that was interesting and surprising. So what they went about is they thought, okay, this must be due to residual heat of pigeon poop. So they spent hours and hours cleaning their device to make sure there's no pigeon poop. And this discovery of what's known as the cosmic microwave back radiation went on to have Penzias and Wilson win the Nobel Prize. And it said it's one of the rare equations in which someone went looking for poop and found gold. I like that story a lot. Further evidence. So this idea of a cosmic background radiation was then verified with the COBE satellite, which is the Cosmic Background Explorer. And what it did, it was a NASA satellite sent into space in November 1989, designed to look for this residual Big Bang. And it was really interesting because it did find a residual temperature, but it also found what's known as cosmic ripples. The fact that this temperature wasn't completely consistent in every single direction. There were slight anomalies, and these tiny fluctuations or anisotropies in the temperature of the background radiation seems to be the evidence of why we have galaxies, why we have certain areas which have distinctly more matter than others. So it's thought these are the seeds of galaxies. So I've explained this is the evidence towards the Big Bang, and we'll very quickly take you through going from the Big Bang to stars. This is a little bit more extra detail than you possibly know for the IB diploma, but it's just amazing about how far back scientists have been able to model. So it's thought that during the first 10 to the minus 43 seconds, yes, 10 to the minus 43 seconds, the four fundamental forces are all unified. So that means, actually, there's been no real complete description of this era. It's just thought that was the case. The temperature was going to be about 10 to the 32 kelvins. After about 10 to the minus 43 seconds, it's thought that gravity splits from the other forces. So we have gravity, and then the three other forces are kind of co-joined at that point. Then up to 10 to the minus 35 seconds, quarks and antiquarks dominate the universe. It's too dense to allow matter to exist as we know it. And then at that point, the strong force separates from the weak and the electromagnetic. So that force becomes present in its own type. And the temperature drops to 10 to the 27 Kelvin. And at 10 to the minus 12 seconds, all four forces become distinct. At about 0.1 seconds after the Big Bang, electrons and positrons form as the temperature drops to 10 to the 11 Kelvin. And after 1 second, the universe becomes transparent to neutrinos, which from now on hardly interact further with matter in any way, because the universe is no longer dense enough to allow that interaction. Step 4, at about 3 minutes after the Big Bang, the temperatures reach 10 to the 9 Kelvin, and protons and neutrons combine to form what become the nuclei of hydrogen and helium, because remember, it's hot enough to allow helium fusion. After about another 30,000 years, the temperatures drop to about 3,000 Kelvin, electrons are captured by nucleum to form neutral atoms, the universe becomes transparent to light, so that means photons stop interacting with the three electrons, and at that point the resulting formation of the cosmic background radiation takes place. So all that light slowly cools down to make the cosmic background radiation we see today. And then about 1 billion years later, the temperature is about 20 Kelvin, and galaxies and stars have started to form via gravitational contraction because of there's certain areas which are denser than others. And remember, we mentioned those indicators we can see in the cosmic background radiation of slight fluctuations in temperature. So after a few billion years, our galaxy forms, and about 10 billion years after the Big Bang, the Sun and the Earth form, and about 15 billion years, which is about now, the background temperature is about 3 Kelvin, which, as we've said before, is what we have observed. And that is the Big Bang, evidence supporting it, and what actually happened. I hope that's useful for you all. So just remember, the Big Bang, singular point at which space and time, matter and energy were created, and the evidence is the expansion of the universe, which we see in the redshifting, background radiation, and the abundance of helium greater than that which could be produced by stars.